Okay, just read this question. We will discuss the assignment first, and after this, we will discuss our next topic, that is Kirchhoff's laws. Okay. Okay. This question was asked in 2015, and uh, it is found that when resistance R is equal to 4 ohm, the current is 1 ampere, and when R is increased to 9 ohm, the current reduces to 0.5 ampere. Find the values of EMF E and the internal resistance. We have to find the value of EMF and the internal resistance. Okay. So EMF and internal resistance means here a cell is given. Here a cell is given, and first we are connecting a 4 ohm resistance with that cell, and 1 ampere current is flowing in the circuit. Hello, Nawal. Hello, Nawal.
Hello, sir.
How are you? Okay. Okay, fine. So Nawal, we are discussing just the assignment. Okay. So let's focus on this question. This is the first question of the assignment, and they are saying that when you will read the question, you will find that uh, you have a cell, and you are connecting first this cell with an external resistance of 4 ohm, and you are getting a current of 1 ampere. And when with the same cell you are connecting a resistance of 9 ohm, you are getting a current of 0.5 ohm, means the current reduces. Okay, and we have to find the value of EMF E and the internal resistance R. So always try to make the circuit of the question, always try to make the diagram. So I am just making the diagram. So suppose here is a cell like this, and this is the internal resistance of this cell, and this cell is connected with first a resistance of R is equal to 4 ohm. Okay, R is equal to 4 ohm is connected, and suppose E is given as, means E is given as the EMF of this cell, and small r is the internal resistance of the cell is given, and they are saying the current of 1 ampere is flowing. So the current is flowing in this direction. From current will flow from positive to negative direction, because if nothing is given in the question, you will assume that the cell is in the working condition, and in the working condition the direction of current is from positive terminal to the negative terminal. Okay, so the current here is 1 ampere is flowing. Okay, now we will write the expression for the current. So what is the value of current? When you will write the expression for this current, you will write current is equal to total EMF divided by the equivalent resistance. Divided by the equivalent resistance. So current I is equal to the total EMF. Total EMF is this. Equivalent EMF or total EMF is this. And what is the equivalent resistance? Equivalent resistance will be the sum of this resistance and this resistance, because these two resistances are connecting in series. Okay, so you will write this as 4 plus R. Okay, 4 plus R you will write, and the value of I is given as 1 ampere, so put I as 1 ampere. You will get E divided by 4 plus R. From here you will get the value of E, that is 4 plus R, and this is your equation 1. This is your equation 1. Now again, when you will read the question, they are saying that Same cell, when you will connect with a resistance of 9 ohm this time, with a resistance of 9 ohm. Now you have connected, and this time this current becomes 0.5 ampere. This current becomes 0.5 ampere. So how you will write the equation of current? Current we have 0.5. Total EMF is E we have, and total resistance is we have 9 plus R. Okay. So from here you can find the equation of EMF E is equal to, that is 0.5 and 9 plus R, and when you will multiply it you will get 4.5. when you will multiply this 9 into this you will get 4.5, and here you will get 0.5 R. Okay, so this is the equation of EMF. We have 4.5 plus 0.5 R. This is equation number 2. Okay, so now we have two equations, this equation 1 and this equation 2, and we have two unknowns. We have two unknowns and two equation. Two unknowns means we have one this unknown and one this unknown. So what we will do, just see both the equation. E is equal to 4 plus R. Here also E is equal to 4.5 plus 0.5 R. When you will compare both the equation, if E is equal to this and E is equal to this, this means that this is equal to this. Okay, so when you will compare equation 1 and 2, then you will get when you will compare, so you will get 4 plus R is equal to 4.5 plus 0.5 R. Now we have to solve for R. Okay, so here is R, and here you can write this 0.5 R, and here is 4.5 minus 4. So here you will get 0.5 R is equal to 0.5. Okay, and R you will get 0.5 divided by 0.5, and the value of R will become 1 ohm. So the internal resistance of a cell is 1 ohm, and now for calculating the EMF you have to put this value of R either in the equation 2 or either in the equation 1, depending upon you in which equation you want to put. So I am putting this value in equation 1. So put R is equal to 1 in equation number 1. So what is equation number 1? E is equal to 4 plus R. So instead of R, just put the value 1. So EMF you will get as 5 volt. The unit of EMF is the potential difference, maximum potential difference. So the unit of voltage or potential difference is volt. So this is your final answer. Means we have find the value of two variables, internal resistance and the EMF. Okay, so this is the first question. This is the first question, and if anyone want to ask anything in this question, then please you can ask if you have any doubt. I want to tell you this is very easy question because we have because we have to just make the equations of current only, and we will solve those two equations and we will get the answer. Here the calculation part is I will say this is a little bit calculating question. So okay, that is fine because you are a student of 12th. You all are the students of 12th, so it is expected that these kinds of calculation you can do easily. And this is the question. Actually now first we will read the question. So here two cells of EMF, this 1.5 volt and 2.0 volt, having the internal resistance of actually this question here is some misprint. So here is this is internal resistance, so unit of internal resistance will be ohm, and here also you will write not this is watt, this is not watt, this is ohm. So here internal resistance, just read again. Yeah. two cells of EMF 1.5 volt and 2.0 volt having internal resistance to 0.2 and 0.3 respectively are connected in parallel. Calculate the EMF and the EMF and the internal resistance of equivalent cell. So we have two cells and we are connecting those two cells in parallel. We are connecting those two cells in parallel. Means this is the condition we have. And I have not told you about the parallel combination of the unequal cell. 1.5 volt and this having the internal resistance of 0.2 ohm. And here is this 2 volt and having the internal resistance 0.3 ohm. So here two cells are connected end to end, so means this is the parallel combination. And one thing more I want to tell you, the parallel combination of unequal cells, parallel combination of cells means parallel combination of unequal cell is not is the part of your syllabus now. I have just taken this question as because in the competitive examinations you can get this question, so just for that I have taken. And actually one thing more I want to tell you, I think here we have solved this question. Yeah, see this. This is the same question, means here also in this question, here also two cells are connecting parallelly. Two cells are connected in parallel. Two cells are connecting in parallel and they are different cells because they have different EMF and different internal resistance. You can see here. Okay. So equivalent EMF and the equivalent internal resistance for the parallel combination is this. So for the parallel combination, if you want to find the equivalent EMF or you want to find the equivalent internal resistance, this is internal resistance and this is given by this. So just make the equivalent circuit. What is the meaning of equivalent circuit? Equivalent circuit is a circuit in which we replace all the cells and all the internal resistances and make them a single resistance, single equivalent resistance. So this is the equivalent circuit, and here is this is E equivalent and this is R equivalent. Okay, so we have to find this E equivalent and this R equivalent. So just you can find it very easily. R1 is given. R1 is given to you. You can choose any cell as 1, any cell as 2. I am supposing this as cell 1, this as cell 2. Okay. This is very easy question. Just you have to put the values in the formula. So you can take E1. Here, what is the value? E1 is 1.5. See here, this is EMF of first cell, that is E1, 1.5 volt. And R1 you will take 0.2 ohm. And similarly, E2 and R2. E2 is 2 volt and R2 is 0.3 ohm. Now put all the values in this formula. If you want to find the E equivalent, then put the value of here E1 R2 plus E2 R1. You will get the answer. E1 is 1.5, R2 is 0.3 plus E2 is 2 multiplied by R1. R1 is 0.2 divided by R1 plus R2. So this is 0.2 plus 0.3. You will get the answer as this will become 0.45. 0.45 this will become 0.45 and this will become plus 0.4. Okay, and here you will get 0.5. Okay, you will get 0.5 and this will become 0.95 and this will become 0.5. 0.50. So your answer is equal to 95 divided by 50, and I am supposing this calculation you can do very easily. Okay, so you can cancel this with the help of 5 further, and you can get your answer. So I am just cancelling it with 5. 510, this will become 5 and the 5. So the answer will become 19 divided by 10. So the answer is 1.9. Okay, 1.9 volt is the equivalent EMF. And for the internal equivalent internal resistance, you have to again put the values. What is R1? R1 is 0.2 na? R1 is 0.2. R1 is 0.2. This is 0.3. And here 0.2 plus 0.3. And here when you will multiply this, you will get 0.06 here, and you will get here 0.5. When you will remove this point, you will get 20 here. When you will remove this, you will get 30 here. So accordingly, you will get your answer. 20 is cancelled like this. So you have 60 divided by 5, that is 12 ohm. So the internal resistance is 12 ohm, means equivalent internal resistance is 12 ohm, and equivalent EMF is 1.9 volt. Okay. So if you want, you can leave this question. This question is not now the part of your syllabus. Okay, so this formula is not the part of your syllabus now, because the combination of parallel of two unequal cells is not in your syllabus. Okay, just taking the third question, and I will say this will good question, and all of you please focus here now. And this question is very good question, I will say. Okay, just read this question first, all of you. From the graph we have to solve. Okay, from the graph, this graph is given. So see the question, they are saying just mark this question as 1 star. This can be this can be appear in your exam also. Okay, maybe appear in your exam. So just read the question. The plot of variation of potential difference. Plot means this graph. The plot of variation of potential difference across the combination of three identical resistances in series versus the current is shown below. What is the EMF and internal resistance of each cell? So they are saying three cells are connecting in series. Three equal cells are connected in series like this. Connected in series like this. And here suppose you can connect either a resistance with this cell or not given, so I am not connect. So just you can connect an external resistance also. Okay, because if you are connecting a cell in the circuit, so definitely there will be some load also, resistance also. So each have EMF E. If I am supposing identical cells, so I am supposing each cell have EMF E and internal resistance R. Okay, this cell also have the EMF E and internal resistance R, because these are identical, and they are connecting again in series, and this is the series combination. We have already discussed this, because here negative terminal is connected to positive, negative terminal of one cell is connected to positive terminal of another cell. So now okay, so can anyone tell me what is the equivalent EMF of this circuit? What is the equivalent EMF of this circuit, Matthew? These cells are connected in series.
So E plus E.
E plus E.
Very good, very good. Means you are right, Nafisa. Very good. E plus E plus E. Because simply we have to add. These are the series combination. This is the series combination. Okay. So this will become 3E. Equivalent EMF is become 3E, and similarly the equivalent internal resistance also become R plus R plus R, because this is a series connection. This is become a small r plus a small r plus a small r. This will become 3R. Okay, this will become 3R. Now, one thing is very important here. Just make the equivalent circuit of this equivalent circuit. What is the meaning of equivalent circuit? We will replace all these cells and just connect a one cell. Okay, like this. See here, this is the one cell I am connecting here, and here our resistance is connected. See, this resistance, they have not talked about this resistance is connected in series. You can connect it or not, it depends upon you. Okay, so this is the equivalent circuit of this. So here what you will write, instead of all these cells, you will write here E equivalent, here you will write R equivalent. And now just see this cell, and this cell is in the working condition. Always, if not given, just consider the cell is in the working condition. And one thing more I want to clear here, they are saying potential difference. They are saying the potential difference. They are saying if there is a potential difference, and they are not talking about the maximum potential difference. Here is some potential difference, means there is some potential drop. There is some potential drop. That means you can say the cell is in the working condition. Okay, cell is in the working condition. So here I have made this equivalent circuit now. This is the equivalent circuit. Now we can write the potential difference across the terminals of the cell. This cell is discharging. This cell is discharging. So I can write the potential difference V is equal to E equivalent minus I into, here is, suppose I current is flowing. So here you will write R equivalent. So this is the equation you have now. So basically this graph is plotted with the help of this equation. Okay, this is the equivalent equation you will get. So now just see the graph. Now just see the graph. Okay. This graph is in between the potential difference on the y-axis and the current on the x-axis. So just suppose you are here at origin. When you are at origin, you will find the value of current is 0. When the value of current is 0, then the value of potential difference, that is V, equal to 6 volt. Okay, when the current is 0, here you will find, from the graph you will find, when the current is 0, here the potential difference is 6 volt. Okay, when current is 0, now all the things of this circuit, all the things of this circuit is decided by the graph given. Okay, so in the graph, when current is 0, V is given as 6 volts. Now put this I equal to 0 and V is equal to 6 volt in this equation. Okay, so just put V is equal to 6 volt, and this is E equivalent minus I is 0 this time, and this is R equivalent. So you will get E equivalent is equal to 6. You will get E equivalent, and what is the value of E equivalent we have found? E equivalent is equal to 3E, that is equal to 6. So from here you will get the EMF of a single cell as 2 volts. 2 volts you will gate. So they were asking what is the EMF and the internal resistance of each cell. So EMF means 50% of the question we have solved. Now we have to calculate the internal resistance. Okay, just look at the graph once more. You are at the origin earlier. Now come here. Now come here. See here, what is the value of potential difference here? Here, this you are on this axis. If you are on the current axis now, on the current axis, the potential difference will be 0. And what is the value of current here? The value of current here will be 1 ampere. Okay, so you will write, when current is equal to 1 ampere, potential difference equal to 0. Okay, so now put this thing in this equation. Put this thing in this equation. This thing in this equation. So just put V equal to 0, and you have E equivalent. Okay. Okay. And we have current now. We have current now. What is the value of current? You will put 1 as a current, and you have to find this R equivalent. Okay. So now from this equation you will get R equivalent is equal to E equivalent, and what is the value of E equivalent? E equivalent is equal to 6. E equivalent is equal to 6 now. So 6 ohm you will get the R equivalent. R equivalent you will get the 6 ohm. And what is R equivalent? R equivalent is equal to 3R. And this 3R is equal to 6 ohm. So R from here you will get as 2 ohm. So what the answers we have now? So the thing is that in this question, you have to apply your mind little bit. You have to think accordingly. Okay. So you can check in this question. Just check, all of you. We have not just did anything extraordinary in this question. I have not did anything extraordinary. I have just applied these same concept that I have told you many times. I have just applied this simple concept. You can also solve this question easily. I have just made the equivalent circuit. And how many times you can say that I have made the equivalent circuit. Many times we have. And according to the graph, now I have solved the question. Okay. So I will say this will be a good. This is a good question, and okay, just you can take, all of you take the screenshots, because it will take save our time. Okay, in writing you can write, but when we discuss the assignment, you should take the screenshot. Okay, all of you, Nawal and Matthew, Nafisa.
Okay, sir.
Yes, sir.
Can you scroll a bit up and show that graph question?
Oh, sorry. Okay. This is the first question. All of you, just please, I request you to take the screenshot, and because we have a limited time. Okay. All of you, just take the screenshot of this, and I will scroll down. You can ask me. Okay. Please don't hesitate in the class. If you want to ask anything, just you can ask. Taken?
Yes, sir.
Matthew,
Yes, sir.
taken the screenshot.
Yes,
Because why I am telling to you that you should note this solution, because I want that theory is important, but not that important. In the examination, you have to solve the question, and you should solve the question like that I am solving. Means there are the different ways to solve a single question, but I want that you should develop the thinking how to solve the question, and when you will revise this solution, when you will see this solution again, you will get into it. Okay. So I'm just scrolling it down. Just take the screenshot of this now.
Yes, sir, taken.
All of you taken?
Yeah, sir.
Okay, very good. Just take this now. Please don't hesitate to ask anything in the class. You are always free to ask. Not anything means about the syllabus you can ask me. Okay, taken?
Yes, sir.
Yeah, sir.
Okay, Matthew. Now just take this. Because these questions are very, very important. You will get, believe me, you will get the same question in your examination, but data will be changed only. Same question. You can leave this question, but take this screenshot.
Yes, sir, taken.
Very good. And I will say, please revise this question at least 2 times. Revise this question at least 2 times. Taken, all of you? Nawal?
Yes, sir, taken.
Nawal, taken?
Yes, sir.
Okay, fine. Matthew?
Yeah, sir. Yeah.
Okay. Okay, just take the screenshot of this.
Yes, sir, taken.
Okay. All of you taken?
Yes.
Okay, fine. Just now take this last. And one thing more I want to tell you, because please don't ignore it. You are taking the screenshot, and please arrange the screenshot in a proper manner. Otherwise, you will not get anything. Okay, means it will be like that. We have wasted our 40 minutes. From the 40 minutes, I was discussing the assignment on.
Yes, sir,
Okay,
taken.
okay, fine. Okay, just now ready for the next thing. And I am saying it why? Because the topic is Kirchhoff's law, and this topic is very, very important again for the exam point of view. Okay. I can also understand that sitting for 1.5 hours and taking the class regularly and some hard questions and not easy task. Okay. For me also it is not an easy task. But we have to do this. Okay. Not always we will do this. There will be a time when you will be free from the classes. When after the exam you will be free. There will be no classes. Okay. I will be also free. You will be also free. So okay. So Kirchhoff's laws, or sometimes this is also called the Kirchhoff's rule or law, you can say. And just I want to discuss something about it, about the Kirchhoff's laws. So till now we have discussed the series combination and the parallel combination of the identical cells, and some cases we have discussed for the uh, series and the parallel combination of resistances, and we have also discussed the series and the parallel combination of capacitors. Okay. So uh, what is the combination, or what is the circuit? Basically, what is a circuit? Circuit is something you are connecting the resistances, you are connecting the cells, you are connecting the capacitors. Okay, and from that circuit, what is the use of the circuit? From the circuit, actually, we want to get some output. You, if you have seen the motherboard of your laptop, um, maybe you have not seen, then you will see there will be circuits. Okay, there will be a wiring and all that. Capacitors are connected, and some mm, IC and semiconductor devices are connected. So basically, I want to tell you that uh, you will not always find that the resistances are connecting in series. You will not always find that the resistances are connected in parallel. The parallel and series combination is just a part of the circuit, a small part of the circuit. We can connect the resistances, cells or capacitors in different ways. So there we cannot apply the formulas for calculating the equivalent resistance that we have applied in calculating the parallel and the series combination. That is 1 upon R for parallel. 1 upon R is equal to 1 upon R1 plus 1 upon R2, like that. Means those formulas will not be valid in that case. So I don't know whether you are getting or not, but uh, I want to tell you that why we are studying the Kirchhoff's laws, because uh, there will be some circuits you will face the questions, and there will be some circuits. Then in that circuit, you will not find any combination. It is very difficult in that circuits to find the answers of the equivalent resistance, current, and voltages. And those circuits are solvable with the help of Kirchhoff's law. Okay, that is why we are studying the Kirchhoff's law. Those circuits which are not possible to solve with the concept of the equivalent circuit, or you can say series or parallel combination, those circuits are solvable by the Kirchhoff's laws. So there are two laws. Kirchhoff basically is a name of the physicist or scientist, you will say. He has given two laws. So I will discuss two laws. What are the two laws? And after that, we will apply the Kirchhoff's laws on the circuit and we will solve the question. Okay. And question may become lengthy, but you have to be patient. You have to be patient. So two laws are given. So Kirchhoff's first law. Kirchhoff's first law is first law. First law of Kirchhoff is based on the conservation of charge. Based on the conservation of charge. Conservation of charge means the amount of charge leaving a conductor or entering a conductor is same. Just see this. This is also known as Kirchhoff's current law. Okay, or this is also known as junction rule. Junction law, or in short form we say it as Kirchhoff's current law, KCL. Okay. So what is the meaning of this? Suppose here is a wire like this, and this is a wire like this, and this is a wire like this. Okay, and in this wire the current is flowing like this, and this is the junction point. This is the junction point, means where three wires are connected is the junction point. Okay, So suppose this is a junction point. So according to this law, suppose I1 current is flowing in this wire and I2 current is flowing in this wire and I3 current is flowing in this wire. You already know this law because you can write this I1 plus I2 is equal to I3. You can write this now. We have already did because I1 and I2 is equal to I3. Okay, this is the law, but we have to define it. So now, according to this law, according to this law, the algebraic sum of currents at the junction is equal to 0. Are you getting my voice, all of you?
Yeah,
Yes,
sir.
sir.
I should check my internet connection. Oh, the speed is very um, okay. Now it's fine. Uh, if you are not getting my voice and if you are getting my some interruption in my voice, and then you can inform me. Okay. So this law says that according to this law, the algebraic sum of currents meeting at the junction is equal to 0. For this, you have to take the sign of the current also. Sign, SIGN sign. So sign convention, you will apply this law with respect to the sign convention. Okay. So sign convention for current, sign convention. First thing is, if the current entering, if the current entering to the junction, then you will take it as positive. Okay. If the current is leaving the junction, if the current is leaving the junction, current is leaving the junction, then that current you can take as negative. You will take this sign convention. This is sign convention, and this is not mandatory. I will say you can take current entering as negative and current leaving as positive. The answer will remain same, but I will advise you to take this. Okay, just so I am taking this diagram again, and now we will apply the Kirchhoff's current law on this wire. So at the junction, the all the currents, summation of all the currents are zero. Algebraic sum of all the currents are zero. Means we will take the current with sign. So if you want to sign of the current, just suppose that you are here. Suppose you are here. Okay. Now if you are here and you have to add all the currents, you have to add all the currents, but you cannot add all the currents like this. Add I1 plus I2 plus I3 is equal to 0. You cannot do this. You have to take the sign of the current also at the junction. If you are adding the current, according to this law, at the junction, the sum of all the current is 0. So now suppose you are here. Now look at I1. So this I1 is coming towards the junction or moving out of the junction? Nafisa, coming towards the junction or moving out of the junction? This current, I1.
Coming towards the junction.
Very good. If the coming means entering to the junction, this current is entering to the junction. So entering current you will take as positive.
Positive,
Okay.
yes.
So you will take this plus I1. Okay. Now Nawal will tell us that what is the sign of I2? Means this I2 is entering or leaving, or what is the sign of I2?
It's positive.
Yeah, very good. Is again positive. Now Matthew, what is the sign of I3?
Minus because it's zero.
Very good, very good. Minus I3, and this all will equal to 0. This all will equal to 0. So in this way we can find this I1 plus I2 minus I3 is equal to 0. And from this equation you can just conclude one more thing. See here you, this is I1 plus this thing, just I am telling just for the interest. I2. You can say here, this is the current entering, this is the current leaving. So you can say the total current entering to the junction is equal to the total current leaving. So you can write one more statement. Current entering the junction, and the junction is this, na? The meeting, this point is the junction point where all the wires are meeting. Current entering the junction is equal to current leaving the junction. And there is one note point here. I will write. This law is based on the conservation of charge. This law is based on the conservation of charge. Conservation of charge means, see here, why this law is valid? Why this law is valid here? Why we can write this as this equal to 0? Because suppose some water is flowing from this wire. Some water is flowing from this wire. Suppose you can. Now this is just for understanding. You can say, suppose 5 liter of water is flowing. Suppose this wire, suppose as pipe, and this current and charge suppose as the amount of water. Charge, you can suppose the amount of water. This is equivalent to charge. This is equivalent to charge. So suppose 5 liter of water is flowing from this wire and 3 liter of water is flowing from this wire, no, not wire, from this pipe. I am saying that suppose this wire has a pipe, so this is flowing. Okay. Now I am not talking about the current now. I am just talking about the charge, because charge and current both are same things, not the same thing. Charge in motion is current. Charge in motion is current. Okay. So 5 liter of water is here. So from this pipe, 5 liter water is coming. From this pipe, 3 liter water is coming. Here, what is the value of water? 8 liter. So same is the case with the charge. Suppose some 5 coulomb of charge is coming from here and 3 coulomb of charge coming from here and 8 coulomb of charge you will then you will get the 8 coulomb of charge flowing in this wire. So that is why this law is based on the conservation of charge. Conservation of charge. So charge is conserved. Okay. So now we will solve one question on it, and the question is very easy. Question is very easy. Suppose this is a junction point and you have 4 wires like this. 4 wires like this, and can anyone solve this question? Means just listen first. This is the direction of the current, and this O point is the junction point. All the 4 wires are meeting at this point, and we have to find the magnitude of this current and the direction of the current. So what is the meaning of the direction? Means whether the current is entering the junction or whether the current is leaving the junction. Just you have 3 minutes. All of you just please try it. You can check your notes if you are getting problem. I want that you should solve this question by yourself. Otherwise, I will to solve it after that.
So can you scroll a bit up? I missed a bit of the notes.
Okay. Okay. First, what you should do? First, note this down. All of the things. Just after that, you should solve that question. Okay. First, note this down. All of you just note it down. Please don't think physics is very hard subject. Please. I know that physics is very easy, but you have to try to understand the physics. And I am not saying that you have to make a aeroplane and all that. That kind of physics you should know. You are just studying this very basic physics. Actually, one thing I want to tell you, the problem is it not with physics. The problem is with the mathematics of a student. They know all the definitions and all these things, but what happens? So I am telling you one thing. The starting of the physics is we have this nature, we have this fan, we have AC, we have electric bulb, we have mouse, phone, and all these things. We have wind, we have air, sun, okay, we have earth, we have stars, all these things. Or you can ask me to scroll down. Okay, uh, what happened uh, we know that the earth revolves around the sun, and in atom there are electrons and protons and neutrons, you may know. In 10th class also, you have some topics like AC generator and all that. But what the difference is that, suppose I am applying a force on this. Okay, I am applying a force on this. But I know that I have applied the force and this body is moving. But without the use of mathematics, I cannot totally understand the physics. I cannot say that how much force I am applying, with how much speed this mobile phone will move. This will be given with the help of mathematics only. Okay. So mathematics is equally important while you are studying. I am not saying that very hard mathematics is required. Very basic mathematics like addition and subtraction and solving of equations, basics of differentiation and basics of integration and all that. You can just feel the physics, but you cannot just completely understand the physics without the help of mathematics. Okay, completed, Matthew?
Yes, sir. Yeah.
Okay, just complete this. This is also completed. Okay, all of you please just put it down. And after that, solve that question.
Sir, I solved.
Okay, very good. What is the answer?
Yes, sir.
It's -4.
Okay, we will check it. Nabal, what about you?
Yes.
Have you solved this question?
Yes, sir.
Okay. And have you completed this? All noted this? All of you?
Yes, sir.
Okay, just now I am solving. You can check your answer and you can check your answer by yourself. No need to tell your answer to me. Okay, now we have to apply the Kirchhoff's current law at the junction. Kirchhoff's current law. So according to Kirchhoff's current law, the summation of algebraic summation of the current at the junction is equal to 0. So now this current is entering, so you will take this as +2. This current is entering, this current you will take as 3 +3, and this is leaving, so you will take this as -1. Okay, and if you do not know about this current, so do not take any sign. Okay, do not think, just write this as +I equal to 0. Now you can solve this
Sir, we
question.
can also
So,
use the current entering the junction equal to current leaving
of
the
course,
junction.
fine, it is fine. You can use that. No problem. You can use that. But I will solve from that also. Okay, just see this. So this will become 5 minus 1 plus I equal to 0. From here you will get I as -4 ampere. And according to the sign convention, means the current is leaving and the value of current is 4 ampere. Why the current is leaving? Because sign is minus here and we have considered negative sign as, see here, current leaving as negative. And if you are doing that question from a current entering and current leaving, okay, so what you have to do, you have to consider the sign also for this. Okay, and from
Yes.
that also, see I am just solving from that method also. So we do not know what is the value of current here, we do not know, but you have to take a sign here. Either you will take, there can be two possibilities in this wire, either the current is leaving or either the current is entering. Either the current is leaving or either the current is entering, but I do not know whether the current is leaving or entering. Okay, so just I am supposing here I am just supposing here current is entering. I amount of current is entering. So I will apply here current entering is equal to current leaving at the junction. So current entering is 3 plus 2. 3 plus 2 is equal to current entering, and this current is also entering. You will take this also as entering current. So you will take this as plus I, and here what you will take? Here what you will take as this is 1. This is current leaving now. Okay. So from here you will get 5 plus I is equal to 1. So here you will get I is equal to, just listen first, 1 minus 5. 1 minus 5 you will get, and here you will get minus 4 ampere. Now the problem here is this negative sign shows that you have considered this direction as wrong direction. You have considered this direction as wrong direction. Why you have considered this direction as wrong direction? Because your output current is negative. Okay, so this you have to remember here. Okay, you can miss this point. That is why I recommend you to solve the question by this, because in this when you are solving this, in this the sign convention is already included, but here the sign convention is not included. You are just deciding, your sign. Okay, so this negative sign shows that, just don't confuse, you can solve it. Negative sign shows that our assumed current direction is wrong. Wrong means either the current will leaving. So you will say the current will minus 4I. We have just considered this direction of current. It means the current is entering. So you will say current, you will say 4 ampere current is leaving. 4 ampere current. So Matthew got it?
Yes, sir.
The difference of the two methods. You cannot say that here the sign convention is not included. So you cannot say this minus 4 ampere. You cannot say this minus 4 ampere is the current at leaving to the junction. Means okay. So this you have to remember. Okay, just note it down. Hope all of you have understood.
Yes, sir.
So I will recommend you. I think this method will look like a little bit complicated from this method, but here you will get confused. Why? Because if you are getting a positive sign I as positive, then it is okay. Your assumed current direction will be same. But if you are getting a negative sign, that you have to change the direction of the current. Okay. But what about the magnitude? The magnitude part will remain same. So this is all about the Kirchhoff's current law. Now we will discuss the Kirchhoff's voltage law. Noted all of you?
Yes, sir.
Okay. And if you have any confusion, all of you, in this question, in this solution, and in this solution, so you can just ask. Just wait a minute. The second law is based on the conservation of energy. The second law is based on the conservation of energy. So according to the Kirchhoff's, and second law of Kirchhoff's is the Kirchhoff voltage law. Kirchhoff's voltage law. Okay, and this law is also known as Kirchhoff loop rule. Loop rule means we will apply this in a loop or a mesh. You will see this. Second law. Now please concentrate. I will say I will suggest you that concentrate on the screen, because you will find this law is little bit more complicated from this. Okay, little bit complicated, because you have to take the potential drop and all that. So just focus. This is here is Kirchhoff's voltage law. Voltage law, or this is also known as the loop rule. Loop rule. So according to this law, according to this law, algebraic sum of all the voltages in a closed loop is zero. This is the statement. Okay. Please have patience. Means you can write summation. This is a sign of summation of Vi is equal to 0 and I is equal to 1, 2, 3 and 4 and so on. I is an integer, positive integer. Okay. Now leave that. So the main thing here is the sign convention. Sign convention is very, very important. Sign convention means rise in potential you will take as positive, fall in potential you will take as negative. So what is the meaning of that? What is the meaning of that? So okay. So suppose you have a cell or a battery like this, and this H and this is L. H means higher terminal, means terminal at higher potential. Cells have two potential. One terminal can be at lower potential, another terminal can be at higher potential. L for lower potential. Okay. And suppose if you are moving in a circuit, and this is just the part of the circuit, and when I will explain you all the things in a circuit, then everything will be clear. So suppose if you are moving from here to here in this direction, if you are moving in a circuit, if you are moving in this direction, Okay, if you are moving in this direction, then you will find that you are moving in the direction of decreasing potential. Means here is the higher potential, here is the lower potential. And suppose E is the EMF of this cell. So this EMF you will take as negative. Means the potential is falling. Potential is falling. If the potential is falling, then EMF of the cell you will take in this negative. Now second case, this is the same cell you have, and now you are moving in this direction. Now you are moving in this direction. So if you are moving in this direction, you are moving from lower to higher potential, means the potential is increasing, rise in potential. Then you will take this E as positive because there is a rise in potential. So this is the conditions for the cell. In a cell, either you will move from higher to lower potential or from lower to higher potential. Now, another case is, suppose you have the resistance R and the current is flowing in this direction. And the current is flowing in this direction and you also moving in this direction. Means you are moving in a wire from this direction to this direction. And the potential difference across this resistance is equal to IR. V is equal to IR. Okay. Now you have to decide which sign of this IR you will take. We already know that the current always flows from higher potential to lower potential. Higher potential to lower potential. And if you are moving in this direction, it means you are moving from higher potential to lower potential. Then this means that the potential is falling. So you will take P is equal to IR as negative. Okay, because if you are moving in this direction, then here in this direction there is a fall in potential. You can check this with the help of direction of current, because direction of current is the direction of decreasing potential. So if you have the resistance like this and the current is flowing in this direction, and here is current I, and here is the potential IR, potential difference IR, and if you are moving in this direction, then you are moving in this direction. Now see, you are moving in the opposite direction of current, and opposite direction of current means you are moving towards the higher potential, because the current flows from lower potential to higher potential, from higher to lower potential, and you are moving in the opposite direction of current, means you are moving from lower to higher potential, means you will take this V is equal to plus IR. V is equal to plus IR you will take if you are moving in this direction, because there is a rise in potential. And everything will be clear with this example. Everything will be clear with this example. Okay. With this example, suppose you have this type of connections. Okay, you have this type of connection, and here one resistance also connected. This resistance is R1, this is R2, and the direction of current is in this direction. The current is flowing in this direction. Okay, like this, the current is flowing. Means this is the circuit you have. Okay, and this is the closed circuit. This is the closed loop also. And you have to apply in this closed loop the Kirchhoff's voltage law. Kirchhoff's voltage law. So this is higher, this is lower, this is higher, this is lower. Okay. Suppose this point is A, this point is B, this point is C, this point is D. And I current is flowing in this circuit. So you can choose any path. You can choose any path whether in the direction of current or in the opposite direction of current, depending upon you. So first I am choosing a path in the direction of current. So in the direction of current means I will move like A, D, C, B, A. You have to choose a path first. Path I am choosing A, D, C, A, D, C, B, A. B, A means I am moving like this. Anti-clockwise. So now from A to D, what you will write for the potential or for the voltage here, if you apply here Kirchhoff's voltage law, then according to Kirchhoff's voltage law, the summation of the current, summation of the voltages, okay, is equal to 0 in a closed loop. So if you want to take, here is one voltage now, there is a voltage here across this, and there is again a voltage here, and there is again a voltage here, means we have 4 voltages or 4 potential differences we have. And suppose this is E1 and this is E2. So you are moving from A to D, so you will take this as minus IR2. If you are moving in the same direction of current, you will take this as minus IR2, because you are moving in the direction of decreasing potential. You will take this as minus IR2. Now when you are moving from here to here, you are moving from lower to higher potential, means you will take this as plus E1. Okay, now you will move from C to B, means you are moving in the direction of current. Again, here current is I. Again, you will take this as minus I R1. And now, finally, you will move from B to A. B to A means you are moving from lower potential to higher potential, means you will take this E2 as positive. And this is all equal to 0. This is all equal to 0. Now you can write this as E1 plus E2 minus IR1 minus IR2 equal to 0. So this is the final equation you will get. So in this way you have to apply the Kirchhoff voltage law. So now suppose what I am doing, I am taking this same circuit and I am applying this law in some different way. Just please have patience. All things will be cleared. I am not saying take the direction that I am taking. You can choose your direction also. Okay, now let's see. Okay, this is the path I have chosen in the direction in the same direction of current. Now I am choosing a path in the opposite direction of current. So direction of current is this. Now I will go like from A, B, C, D, A. I will choose a path A, B, C, D, A. So now I am moving like this. In this direction I am moving. Clockwise I am moving. So we will see whether the result will be same or not. Now see here. You can see here. You are moving from here to here to here. Now here is some potential voltage we have. We are moving from higher to lower. We are moving from higher to lower. Potential means E2 will be positive or negative, Matthew? E2 will be positive or negative?
Negative.
Very good. E2 you will take negative. And now from A to B, all things are completed. Now move from B to C. So from B to C, you have to remember that you are moving in the opposite direction of current. You are moving in the opposite direction of current, and here potential difference is IR1. And you have to choose the direction of this IR1, whether it can be positive or negative. There are two possible ways. So you are moving in the opposite direction of current, and in the opposite direction of current means the potential is increasing. So you will take this IR1 as positive. Okay, now let's see this. From C to D, you are moving from higher to lower. Again, you will take minus E1. And now from D to A, you are moving in the opposite direction of current. You are moving in the opposite direction of current. Again, current is I. Here the potential drop is IR2, and you will take again this as plus IR2 is equal to 0. Now we will see whether that, now take the minus sign common from all. So this will become E1 plus E2 minus IR1 minus IR2 is equal to 0. So now you can see both the results are same, whether no matter which path we are choosing. You can see this result and this result all are same. Okay. So do you have any doubt, Nawal, Nafisa, and Matthew?
No, sir.
Matthew, your voice is cracking.
No, sir. No, sir. No.
Nawal,
No, sir.
okay, and Nafisa,
No, sir.
you have to take the directions accordingly. Okay, means you can choose any path according to you, and you will get the same answer. No problem. Uh, okay, but you have to remember whether you are moving in the, when you have the resistance, then you have to check whether you are moving in the opposite direction of current or in the same direction of current. If you have a cell, then you have to check whether you are moving from higher to lower or lower to higher potential. Okay, just note it down, all of the things. Sign convention is very important here, and you will see in the next class we will solve a question. Now our time is up now, so because the question of the Kirchhoff's laws sometimes are lengthy.
Sir, please scroll down.
Nafisa and Nawal, should I scroll down?
Yes, sir.
Okay, fine. Each and everything is important that I have written here. I into R is equal to potential, or is equal to voltage or the potential difference. The product of I V is equal to IR now. So that is why we are taking IR1. Okay. You can ask me to scroll down. Okay.
Sir, can you scroll down?
And one thing more, I am choosing a path na. You can choose any path, C, D, A, B, but you cannot choose a path. This is not a path. If you will say that I will choose a path C, A, D, B. This is not a path. This is a path C, D, A, B, B, A, D, C. Accordingly, you have to choose the path. And this thing is na. This thing is we have just applied the KVL, Kirchhoff's voltage law. Means summation of the voltages, summation of this voltage, summation of this voltage, which sign we are taking is equal to 0.
Done, sir.
All of you completed?
Yes.
Yes, sir. Yes, sir.
Okay, fine. Just note it down. So just last point I want to write here. This law is based on the conservation of energy. Conservation of energy means you can say the energy given by the cells, because what is the use of the cell? Cell have the stored energy, stored chemical energy, and that energy cells gives in the form of electrical energy, and that energy is dissipated across the resistances. Means the amount of energy given by the cell is dissipated across the resistances. Means no energy is created or no energy is destroyed. Means energy is conserved. So that is why this law is based on the conservation of energy. Energy given out